Let's start by ignoring most of the stuff on the right, which there's nothing wrong with, but I like to present it slightly different, so you don't have to cross it out of yours. I'm just telling you I'm not going to use it. Okay, Megan, we need our first person. Other way. There we go. There. Oh. It's a good start. You're exempt if that was yours.
Yeah.
The number's on the backside, probably. Oh, we weren't sure if it was an I? No, the white ones are B, so. So 1. So we got Mikey. So I'm using the old school number symbol. Mike, what's the only way you can get 0 as an answer if you're multiplying two numbers? Perfect. So if you're multiplying two things and it's equal to 0, you know that this is equal to 0 or this is 0. We don't know which one. I should say, let me write the word is, maybe that'll help a little bit. Now, if I were you, at the top of your page, kind of in that left-hand side where I scribbled out, I suppose I could have just written it there. The left-hand side where I scribbled out stuff should be open. I would put this right there and circle it. Hold on, just let me copy and paste. That'd be easier. Oh, son of a gun. What? Why is it not letting me do that? Okay. Yeah, I'll just leave it there. I would put it in this open space right here and circle it. So that entire idea is how we're getting answers. Megan, you want to roll again? 20. I don't have numbers on here yet. 18, 19, 20, 21. Carly. Oh, you knew you were 22. You just didn't want to volunteer that. I got you. Okay. Oh, what the heck, my voice. Carly. When we factor something, how do we write the answer? You don't know? You forgot an entire 4 weeks of schooling? Oh, geez. Nearly all of our problems, we wrote it as 2 parentheses like this. That's what I was looking for. Do you remember that part? Okay. When you write those parentheses next to each other like that, what does it stand for? What? You didn't forget how to like do math. Add, subtract, multiply, divide. When you write two things next to each other, like two, multiply. So we never write the multiply symbol between parentheses, but that's what it stands for. So like foiling, which we learned a while ago, foiling means you multiply out all this stuff. So you guys know it stands for multiply, but it's just not, we've never needed it for that certain purpose. So our goal is we're going to take an equation and factor it and have it equal to 0 to solve. And the whole reason we're doing that is because we know this is 0 or this is 0. So if you're, why did if you're given a complicated equation like a quadratic equation, like squared, we know how to factor those. And part of the reason we learned factoring was so that we could solve them. This is going to be one of the most common techniques to solving a quadratic equation. The next most common one is going to be something called the quadratic equation, which is very different, and some of you will love, some of you will hate. It's basically a big formula you fill out. And so some people like that, some don't. This is traditionally going to be a lot faster, possibly, but it all depends on how quick you are at factoring. But that's the goal of what we're trying to do today. We're going to be given an equation, we're going to be trying to solve it, and we'll do it by factoring. So here, we've got one on the left. I suppose we'll roll somebody, but I get that you guys may have forgotten much of factoring, so we'll kind of do it together. That's Lexi. Lexi, do you remember how to factor x squared minus 49? Oh, just factor this. So you're thinking of solving by doing the opposite. Okay, which isn't a bad idea, but that's not what we're doing. So factoring, a lot of you thought of x squared minus 49 as x squared plus 0x minus 49. And then to refresh your memory, you were trying to find two numbers that multiply to negative 49, add to 0. Does that ring a bell? You guys are staring very blankly. You forgot all this entirely already? No. Lexi, do you remember how to factor it down? Or were you saying, yes, forgot entirely? Oh, okay. Should we go to the next person? Okay. You're making me do all this math. 26, 25, 24, Casey. Oh, you knew already, too, yeah. Do you remember how to factor x squared minus 49? It's going to be a long day, isn't it? Okay. Can I just add, does anybody know what two numbers multiply to negative 49 add to 0? 7 and negative 7. So we would write it as x plus 7, x minus 7. I guess this is probably a good time when we're done with the unit, and I constantly get asked the question, do we need to keep this? Can I throw this away? I don't care what you do with them, but this might have been a good reason to keep it. Then you could actually look at it. Okay, we're going to make this equal to 0 because that's kind of the problem we were given. Say what? Oh, okay. We know that this is 0 or this is 0. Now, when I say the word is, like this is 0, is the English word for equals. So we are basically saying x plus 7 is 0, x minus 7 is 0. And then this is where you would solve them by, subtracting 7. A lot of you just do this step in your head probably. So this is what we'll get as the answer. When I say answer, I do mean solution. Megan. Oh, weird. I saw that when it kind of fell back in. 19. Mason. Do you remember yesterday we used the word solution when we were graphing and you were trying to find where it crossed the line? So both of these numbers are solutions. If I would put 7 in place of x up here, what would be my answer? X represents the number. So you would put 7 in place of x. I kind of get the feeling you're trying to do a bunch of calculating in your head. But we're not needing to. Does anybody, what would be the answer for anybody? 0. We were purposely trying to figure out what number would give you an answer of 0. So -7 and 7 would both give you an answer of 0. I'm getting the impression I should be taking this a lot slower than I was thinking of. Is that true? Is this considered seemingly difficult so far? Mainly the factoring part? Okay. Let's try the second one on the right-hand side. We have this equation that we are trying to solve. She's gone. It happens. It's random. Well, I mean, to be fair, 20s is like more than a third of the class. 2. That's Grayson. All right, Grayson, deep from the memory banks. How do we factor 3 terms when there's a number in the front? And I believe Mr. Caponigri taught it the same way I did. I guess I didn't even think of that part. Because I think you had him for factoring, right?
Yeah.
I guess I didn't even think of that. Did he teach you to multiply the outer numbers? Or did he teach you like the box method, like the X?
No.
Multiply the outside numbers?
Yeah.
Okay. Yeah, I after I asked the question, I guess it dawned on me that it could be very different. So if we are trying to factor 6x squared plus 7x minus 49, which by all accounts, these numbers are large, and they don't have any common numbers for us to make them smaller, we are going to multiply 6 and -49. Holy cow, that's big. Negative 294. That's horrible. This is a terrible example. I feel like I should change the equation for our example. Maybe Grayson, you can answer this. Why am I saying this example is not a great example? Do you remember what we do with the negative 294?
No.
Okay. We're supposed to try to find the factors of 294. And then find the pair that adds up to 7. Wow, that's going to be a big one. Does anybody have that factor calculator open? Let's pretend and cheat and use that. I don't know the 2 factors off the top of my head. All right, let's figure it out. 1 and 294. 2 and 147. Did you just complain about doing math in math class? Oh, well, 6 times 50 is 300. So it's going to be 6 less than that. Okay, 3, does 3 go into that? 11 and 4 is 15. Yeah, 3 goes into it. 29, it goes in 9, so that's 27, 24, 8. 4 does go into that. No, 4 does not. Yeah, 4 does not. 5 does not. 6. Oh, yeah, 6 and 49. Yeah, we know that one. 7, I don't think does. Oh, it does. Ah, let's pretend I knew that. Well, they're still not 7 apart. 8. Yeah, it doesn't seem like it. 9, yes. No, 9 does not because it's 15. 10, no. 11. Oh, now we're getting to big ones. Actually, there isn't going to be many. 294 breaks up into 649, 2 and 3, 7 and 7. So it's not made up of many numbers. So 14, 2 and 7 makes 14 and 21. Ooh, let's stop there. Those are 7 numbers apart. Negative 294 means one has to be positive, one has to be negative. We need positive, so that means positive 21, negative 14. That was an awful lot of work. I'll just tell you right now, I'm not expecting you to need to do that on some of your problems, but let's go through and double check after this. Normally, this number is going to be like less than 50. So you're not going to have to like go crazy to try to figure out factors. Okay, sure. 17. I bet you guys weren't prepared to think this hard today. Bella, what do I do with these 2 numbers that I figured out? See, that's what I was talking about. Like sometimes the roller thing doesn't actually, it just like takes off. Good catch though. It's right by your backpack, underneath your shoe. Bella, do you remember what to do with those 2 numbers we figured out? Perfect. You're going to put them in place of 7. So we're going to have 6x squared minus 14x plus 21x minus 49. Split it in half imaginarily. Megan? Serena's gone. 28, 29, 30, 31. Natalie, do you remember what to do from here? Good. You look for the common factor on each side. So this one looks like we're going to have just 2. Am I reading that right? Yeah. So 2x. This would become 3 single x minus, wait, do you guys want me to show you the full division part? Do you need remembering on that? Okay. This would become regular 7. On the right-hand side, 7 goes into both. Positive 7 does. And this will become 3x minus 7. Whew. Almost done. Mackenzie, do you remember what to do with the problem at this step? So they both have the same parentheses. So that's kind of considered a common factor. So anything that's in common, we usually write in the front. And then when we divide it out, we write what's left over. So in the other parentheses, I would write
2x plus 7.
perfect, 2x plus 7. Okay, now here's a problem that happens all the time. We spent a long time trying to figure this out. And this, I would consider this probably one of the harder ones we've ever done. Does anybody remember why we did this? Why we factored it? Because it's easy to forget, like, it's easy to forget the goal of the problem halfway through.
Isn't that how you graph it?
Kind of. We're trying to find the solutions. And the only way we were able to find solutions is if it was factored equal to 0. So we are going to say the first one is 0 or the second one is 0. So once you get something factored, you're going to solve each individual little factor. Say what? Yeah. We're smart. It's not a big deal for us. Except for the amount of room I have. If you want to write these as decimals, you can. I'm writing them as fractions because I didn't want to do decimals. This one would be 2.3. This one would be negative 3.5. Now, I will fully admit this one is definitely one of the more difficult problems we've done this year. But I would like to say that I'm impressed at how much better you guys have gotten over the year. Because if I would have shown you a problem similar to this near the beginning of the year, you guys would have given up right about at this step. As soon as we had to try to find factors in negative 294, you guys most definitely would have immediately gone to your phones to check your hair, to look at notifications. So I am impressed. You guys stayed with it. So that's good. You should feel good about yourself. Even though you may hate this problem, you should feel good about yourself. I'm assuming you guys would like me to do at least one more with you. Okay, I definitely can do that. This was intended to be the example page, and then you guys would do homework after this, but I am totally okay doing more with you. Should we do this one? Sure. Rather than roll somebody for this one, does anybody remember what to do when they have a number in common to start with? That was supposed to be the first thing we always look for, is do they have any numbers going into them? Maybe we should roll then. Oh, yes, you're going to take that number out. So, 50x squared minus 2, I'm going to write as 2 times 25x squared minus 1. Do you want me to explain where those numbers came from? Okay, sorry. I'll pretend that I didn't do this. If 50x squared minus 2, if I recognize that they're both even, I'm going to divide them both by the number I recognize they both had in common. So 2 went into both of them. So I'm going to divide it by that to get the new factor. But I don't just throw away the 2. I put it in the front because it's a common factor. I only divided by a 2. So we didn't do anything with the letters. The only time you change the letters is if you divide by letters. So when I'm dividing by a regular 2, I only do it on the 50. Yeah, sorry, that's a good question. Does anybody remember how to factor difference of squares? So there's only 2 things here. There's no middle term. So there's a very quick way to do it without actually having to do any work. You can make a middle term of 0 if you want, sure. Because then if you do a middle term of 0, you would be multiplying the outside two numbers, and that would work. It's definitely slower, but it would work. Is that the way you guys would prefer me to do it? Well, so a difference of squares, when there's only two things, I can immediately do the square root of each one. 1 plus, 1 minus. The looks I'm getting make me feel like you did not remember that topic. Would you prefer me to multiply the outside two numbers and go that route? Oh, that's terrible. It's so slow. Okay. You guys, you have to know that I'm lazy and I don't like to do the long way. You guys have a much better work ethic than me. Okay, I'll do this right below it. So 25x squared plus 0x minus 1. So this is the method for multiplying the outside numbers, which will give me the exact same answer that I just erased. So I get negative 25. Look for the factors in negative 25 that add up to 0. 1 and 25, 5 and 5, and positive 5 and negative 5 add to 0. So 25x squared plus 5x minus 5x minus 1. There are four things, so I draw an imaginary line. I am actually pretty impressed you guys remember this method, though. This is traditionally the hardest method for anybody to remember. But it seems like you guys really have this one down then. If it feels easier, you use it. That's fine. There's nothing wrong with it. But that's good. So that's what I'm saying. That's a good thing. So 5 goes into both of these and an x. So if I divide by 5, divide by x, divide by 5, divide by x. Does anybody remember what to do when the first number is negative? Divide by a negative. So they don't have anything in common. I'm just going to divide by negative 1. So this becomes positive 5x, positive 1. I'm now at the step where I can write the final answer. 5x plus 1 is in common. If I took out 5x plus 1, I'd be left with those two things. I'm not really sure how to fit this up here. Let me, whatever, let's cheat a little bit. I'm going to solve each of these separately. Now, I obviously don't have enough room to write a lot of stuff here. Does this work fit on your spot on your paper? Okay, but you write big. No. Okay, divide by 5. And again, a decimal is totally okay. I don't care how you write the answers. Our goal is just to figure them out. I couldn't hear you. Because I subtracted 1? So it became a negative 1 when it's on the right-hand side? Wait, isn't that what you're asking? Or are you asking where did the 5th come from? I divided by 5, but I just really didn't have room to write it. Is that? Is that what you mean? Okay. Something tells me this page is going to take a while. Is that correct? Okay, we've got 20 minutes left today. Maybe we should make our goal to be to do these top two. See how that goes. Let's just aim for those top two by the end of today. Is that a good enough goal to accomplish? Okay, let's try that. And we will definitely work on these more tomorrow because I could see you guys. I can see the fear in your eyes, basically.